Alright, now that we have some examples of using the laws of sine and cosine, we can now use those on application problems to be able to solve problems in the real world. So, a man named James is walking along the road. At one point, he turns off at an angle of 40 degrees and walks 40 meters. Then he turns 60 degrees to get back to the road. How far along the road did James walk? So basically, there's a road, and James, he comes up and he takes a 40-degree turn here. This is 40. Walks 40 meters. Okay. And then he turns 60 degrees to get back to the road. So it makes a 60-degree turn. Okay, so this is 60 degrees, not the angle in there. The turn he made was 60. So because this is, if this were drawn out, that would be 180 degree right there. This is just a straight line. We know that this angle in here is 180 minus 60, or 120. Okay, and we want to know how long he's walked along this road right here. We'll set that to A. Okay, so in order to do that, we have two angles and a side. To find this side, I'm going to find this angle. We'll make that angle B. This angle, and then we'll use the law of sines to find the length that he walked along the road right here. So, since we have an angle of 40, an angle of 120, we can do set angle B equals 180 minus 120 minus 40, and that equals 20 degrees. So now we have an angle and the length of the opposite side, and an angle and the length of a side that we want to find. So we'll set the law of sines up, but side A over sine 120 equals 40 for the value of side B over sine 20, that angle. Multiply both sides by sine of 120, we get A equals 40 sine 120 over sine 20. And we put that into a calculator, and we'll see that A equals 101.28, and we don't want to forget our units, it's in meters. So 101.28 roughly meters is the distance that he walked if he had just walked along this road instead of turning off and coming back this way. So now we can move on to this equation. Alright, and now we're doing this equation, so a man drives 15 miles west, then turns 20 degrees to the north, and after traveling 32 miles in this new direction, he wants to drive straight back to the starting point. How far will he need to drive to get home? And what degree angle will this turn make with a 32-mile segment? So, we'll erase this real quick. Okay, it says a man drives. We'll make that a bit shorter. He drives 15 miles west. Alright, and then he turns 20 degrees to the north. So that's 20 degrees here, which I'm just going to go ahead and say that means that this angle equals 160. Okay. And he drives 32 miles in this new direction. So this length equals 32. Okay, this is this angle. And after driving those 32 miles, he wants to drive straight back home, or straight back to his starting point. How far will he need to drive to get there? And what angle does that make? So this is how far he needs to drive home, so we'll make that side A. And this angle right here is, we'll make this angle B, the angle that it makes with that 32 degree segment. So we have a side length here, a side length here, and the included angle. So we already know from our practice examples that we can use the law of cosine to find this side right here, and then since we'll have an angle and its opposite side, we'll be able to use the law of sines to find this angle using its opposite side of 15. So we'll set a squared equals so 15 squared, which is 225, plus 32 squared, or 1024, minus 2 times 15 times 32 times cosine, the included angle, which is, as we see over here, 160 degrees. Alright, and then we can take the square root of both sides. So A equals the square root of 1249 minus 960 times cosine 160. Put that into a calculator and we can see that A is going to equal 46.38. We don't want to forget our units because we're finding out how far he needs to drive. 46.38 miles is this distance right here. 0.38. Alright, and now we want to find what this angle equals. So we have a side here and the angle opposite it, and then we have a side here and we want to know what the angle opposite that side equals. So we'll just use the law of sines. Alright, so we have sine B over 15 is the side opposite that, so 15 times, or equals, sine 160 over 46.38. Multiply both sides by 15, and we get sine B isolated 15 sine 160 over 46.38. And if we put that in a calculator, let's see that sine B equals 0.111, and we use the inverse sine to get the value of b, it equals 6.35. Alright, that's the value of this angle in here. Yep, we'll redo that. 3, 5. Alright, so we just used the law of cosine and the law of sines to find how far he needed to go to get back home or to his starting point and what degree that made with that segment that we had.